In Module 4, we will talk about data manipulation with NumPy. Let's talk about module introduction and the learning objectives. In Module 4, we will explain the basic of working with data in Python. And we will begin the path with learning how to read and write from the text file. So in the data science, usually our text file we refer to the Excel file or CSV file. Continuing this module, we will uncover the best Python libraries that will end in data manipulation and mathematical operation, which is NumPy. The learning objective for this module, we will demonstrate an open function to create and identify a file object. After you create the file object, you can either read or write to the file. So we will demonstrate how to create a text file by using the open function. And also we will demonstrate how to use the NumPy to create 1D and 2D array. So now the first thing, let's do some introduction about NumPy. We will quickly using the HTML file and provide some Python script to show you the fundamental scripting and the function from the NumPy. In our handout 4, we quickly give you some example from the NumPy. So we will introduce the NumPy fundamentals and how to do the NumPy to do the declaration and operation. We were using the NumPy slicing. We can do the reshape. We also introduce some universal function. In the prior module, we talked about Python. Actually, it's a dynamically typed language. You don't really need to define the variable. We're just using the assignment operator to assign the data, so then they will refer to that. So the Python list is mutable. And also they contain diverse data type. So here when we talk about the NumPy, actually it's a fixed type array type that contains a single pointer to one contiguous block of the data. Python list is a pointer to a block of pointer. So each of which pointer to a Python object. The list provides flexibility, but there is an overhead attached to it. So NumPy actually is a fixed type array. So the array, just like we said before, array is a fixed size. So they have less flexibility, but it's more efficient regarding to store or manipulate the data. So the first thing, let's see how to use the NumPy. When you want to use the NumPy package, you need to import NumPy. So here is the NB just is a NumPy object. Of course, you can change to other name, but usually because the NumPy actually is ND array object, so usually we just write NP as the object name. So here is the example. We can create a 5x3 array of the normally distributed random value. So about the normal distribution data, we will talk about more. A data is normal distribution. That means their average mean is 0 and standard deviation is 1. So we can use using the np.random. So we will invoke the random value. So then the normal mean the normal distribution. Of course, you specify the first one is your mean. The second one is your standard deviation. So the third parameter, that's the size for your array. So we have 5x3. So you have 5 rows, and each one have 3 data. Make sure you copy the example into your Jupyter notebook and see your result. So of course, you can using the NumPy just create a one-dimensional array. So that you have the one-dimensional array have the value. And also you can try to create your NumPy with the random number, specify the range, and also tell me how many array you want to create. So the following example, we're creating a three-dimensional array. So again, we import NumPy. Then you have your random number. You can seed the random number for different random sequence. So we want to create a 3-dimensional array. You will see the size is 3, 4, 5. That's 3-dimensional array. And each element, the value under 15. Then we create the random integer number. So then when you print the result, you will see here, 3-dimensional array actually mean you have 3 times 5, 3 times 4 times 5. So that means you have 3, 4 times 5, 2-dimensional array. So try to type the example into your Jupyter notebook. You can change your seed, so then you will see your result will be different from mine. So NumPy actually have many useful attributes. So here we will see the NumPy you have NDIM. So that means the number of your dimension, what is kind of shape, and what is the size, and your item size. So that's why earlier we create the x3 actually is 3-dimensional array. So then you can see when we use the x3.ndim, so that will be dimension is equal to 3. So the shape, that will be all the dimension number. So the size means total how many elements. So the D type is each element, what is the type for the value. So then you have your item size, that means each element, what is the size. So then your total byte. NumPy slicing will be very similar as when we talk about the list, tuples. So the slicing we will see we use the column and specify our range. So here we have x2. The same thing we use the NumPy, we create a random integer number. Our 2-dimensional array is 3 times 4. The value under 15. So you can see your result. So then you can see here is 2-dimensional array. So that's why when you specify your array name, you will have the 2 dimension. So here we have the column 3 and column 2. That's mean under your third row and under your second index. So that's why here we will have the result like that. So earlier we have 3 times 4. So then here we will until the before index 3, before index 2. So that's why here is our slicing result. And also you can copy your slicing element into another array. After we create an array, we also can reshape our array. So earlier our x2 is a 2-dimensional array, 4 times 5. So now you can reshape to change your dimension. So then become 4 times 3. So how they reshape? Before is 3 times 4, now we become 4 times 3, right? So then you will see actually they just have the element one by one, have your order. So now because you have 4 rows, but each row is 3 number. So that's why you can see they will have 12, 2, 0 as the first row. So then continue, we have the 0, 4, 5. We can back to see our original array. You see you have your first row is 12, 2, 0. But the new array, you only have each row is 3 elements. So then they become the first row. So continue the rest of number, we choose 3 number. Then you become second row, then the third row, then the last row. So that's how we will reshape like that. We also can concatenate the array using the NumPy. So here we have x and y, they are both 1-dimensional array. So then when you concatenate x and y, so you will see they will combine with one array. We also have the split method from NumPy. For example, if you have a list, you have 1, 2, 3, 4, 5, 6, 7, 8 elements. So we can split that into different number of array. So we use the np numpy.split. So with the first argument, you pass the list name. Then you can either have the number element to split into only one array, or you can specify using the square bracket. So here the square bracket, if you have two numbers, that it will split into 3 array, because the first number tell you the first array how many elements. So the first 2 elements into the first array. Then until the 6th element, we will go to the second array. So the first array you have 2 elements. Then the rest of the 4 will go to the second array. So the rest of that will go to the third array. So then you have 2 numbers in the square bracket. So that's why we will assign 3 different arrays. x1, x2, x3. So that's why you have your result. In NumPy, we also have some universal function we can use. So here, for example, we can using the random function. The array is followed with the parameter to give the shape of the random number you want to create. So we want to create 10,000 elements. So then after you create this array, you can using the sum function to find all the element total in the random array. You're also using the max method. So then you can find the maximum number from your random array. Of course, you have your minimum value from the random array. You also can find the mean, the average from your random array. So that's we quickly to introduce some important concept from the NumPy. Please make sure you will copy over all the statement from the handout, and make sure you will paste to your Jupyter notebook, or you can using any Python IDE to test the script.